Have you ever imagined a city built not by humans, but by tiny animals the size of a grain of rice? Welcome to the underwater world of coral reefs, nature's most vibrant and most complex architectural masterpieces. Today, we're going to explore how coral reefs are built, how they function like living cities, and why their future matters to all of us. Let's start at the very beginning. Not with towering structures, not with machines, but with tiny living creatures called coral polyps. Each coral polyp is a soft-bodied animal, related to jellyfish and sea anemones. And yet, these tiny creatures are some of the greatest builders on Earth. Every polyp slowly secretes a hard skeleton made of calcium carbonate, a kind of natural limestone. They attach themselves to rock, or to the skeletons of older corals, and over time, layer by layer, generation by generation, what begins as a single polyp eventually becomes a reef structure large enough to be seen from space. In fact, the Great Barrier Reef is the largest living structure on Earth. Now, reef growth may seem slow. Corals usually grow only a few millimeters to a few centimeters each year. But when you stretch that growth across hundreds, or even thousands of years, you get something truly monumental. It's like building a city one brick at a time, without ever stopping, for centuries. From individual polyps, to colonies, to massive reef systems, nature quietly constructs living underwater metropolises. But a city isn't just buildings. A city needs energy, jobs, infrastructure, and waste management. And coral reefs have all of that. Inside the tissues of coral polyps live microscopic algae called zooxanthellae. Think of them as the reef's solar panels. They use sunlight to produce energy through photosynthesis, and they share that energy with their coral hosts. In return, the coral provides shelter and nutrients to the algae. This partnership is what allows reefs to grow so quickly and shine with such brilliant colors. But energy alone isn't enough. Reefs are filled with specialized workers, just like any city. Parrotfish scrape algae off coral surfaces, keeping the reef clean and healthy. Cleaner shrimp and cleaner fish remove parasites from larger animals, acting like underwater health clinics. Predators like sharks and groupers regulate populations, maintaining balance in the ecosystem. Every species has a role. Every role supports the whole. Even waste is recycled. Fish waste becomes fertilizer for algae. Dead coral becomes the foundation for new coral growth. Nutrients are reused, cycled, and shared, creating a self-sustaining circular economy, one of the most efficient systems in the natural world. Now, let's talk about the residents of these underwater cities. Coral reefs cover less than 1% of the ocean floor, and yet, they support nearly 25% of all marine species. That's more biodiversity, in one small area, than almost anywhere else on Earth. In many ways, reefs are the rainforests of the sea. Here, you'll find complex food webs. Tiny plankton feed small fish feed larger fish feed top predators, and every level depends on the others. Herbivores keep algae from overgrowing corals. Carnivores regulate prey populations. Scavengers clean up organic debris. Together, they maintain the health and balance of the reef. And then there are the adaptations. Some reef fish can change their sex to maintain population balance. Octopuses can instantly change color and texture to disappear into their surroundings. Corals themselves can glow under ultraviolet light, creating stunning underwater displays. These bizarre, beautiful, and brilliant adaptations allow life to flourish in one of the most competitive environments on Earth. But like any city, coral reefs face serious challenges. One of the biggest threats is climate change. As ocean temperatures rise, corals become stressed, and they expel their zooxanthellae, their life-giving algae. This causes coral bleaching, where reefs lose their color and their main source of energy. If temperatures don't return to normal, bleached corals can starve and die. Human activity adds even more pressure. Pollution from land runoff introduces chemicals and sediments into reef systems. Plastic waste damages coral structures and harms marine life. Overfishing disrupts food webs, removing key species that keep the ecosystem balanced. And yet, despite all of this, reefs are showing remarkable resilience. In 2026, scientists and conservationists are using innovative methods to protect and restore reefs. They are cultivating heat-resistant coral strains. They are deploying underwater robots and 3D printed reef structures. They are expanding marine protected areas and restoring coral nurseries. These breakthroughs are helping reefs recover faster and withstand future environmental stress. So why does all of this matter? Because coral reefs protect coastlines from storms and erosion. They support fisheries that feed hundreds of millions of people. They drive tourism economies around the world. And ecologically, they are irreplaceable. But the future of coral reefs depends on us. Everyday actions make a difference. Reducing plastic use. Choosing sustainable seafood. Supporting reef conservation organizations. And advocating for climate action. Each small choice adds up. Now imagine the year 2050. Imagine oceans filled once again with vibrant colors, thriving fish populations, and resilient coral cities. Imagine reefs not as fragile ecosystems on the brink, but as living proof that humanity can coexist with nature, rather than overpower it. That future is possible. And it begins with awareness, action, and care. Thank you for exploring the underwater cities of coral reefs with me today. If you enjoyed this journey, consider sharing it, and helping others see the beauty and importance of life beneath the waves. Until next time, stay curious.